Okay, so today we're going to be talking about the Pythagorean theorem, and we're going to be reviewing all the things we talked about, the distance formula, all that kind of stuff for the test. So again, Pythagorean theorem is something we use with right triangles, and basically it says if we have a right triangle and we take the two smaller sides, those would be the legs, we'll call them A and B. And we take the longest side, we'll call that C, that's the hypotenuse, right? If we square those two smaller sides and add them together, it should equal the square of the largest side. And that is our Pythagorean theorem, the basis for pretty much the entire study of trigonometry. Okay, and it's how we find distance and all that kind of stuff in today's world. So, distance, Pythagorean theorem, all that kind of stuff. That's what we're reviewing today. I'm going to go through this fairly quickly, so you can always pause or rewind. But let's go through and do these. So I'm going to do the evens on the video here. So the first step when you have a missing side, like this problem right here, is to identify which of the numbers is going to be your C, or the longest side, right? Because that one's going to be off on its own on one side of the equation. The other two, it doesn't really matter what you call A and what you call B, because it's going to be pretty much the same thing no matter what. It's going to be something squared plus something squared. So when we look at this one, the longest side is always the side that is opposite the right triangle. So if you draw a line straight from the point or the corner of that right angle, it'll go straight to the longest side. So in this situation, 15 would be the C, right? So that means X is either A or B. So again, doesn't matter which one you think of it as. I'm going to think of it as A, I guess. So X squared plus 9 squared should equal 15 squared. That's how you would set it up, right? 15 is the C, so it just goes on its own side. The other two square, add together. And then you're just squaring and solving from there, right? 9 squared is 81, so X squared plus 81. 15 squared is 225. And then you would have to minus 81 to each side, and 225 minus 81 is 144. So I have X squared equals 144. And this is where a lot of students stop and then they get it wrong, right? Because I'm not solving for X squared, I'm solving for X. So I have to square root to get the X by itself. And if I square root one side, I have to square root both sides. So the square root of 144, again, you just plug that in your calculator. I know it's 12, but I'm just showing you how to plug it in your calculator. Use that button right there. You have to push the second button, and then that button right there. Okay? And you're going to get 12. So X is equal to 12. Now, I know we talked about earlier this year where when you square root something, you should have two answers, right? Positive and negative. But in this situation where we're talking about actual distance, you can only have positive distance, right? So you can't have negative distance. You can't go negative feet backwards, right? Even if you're walking backwards, you're still traveling a distance. So you can't have a negative number be distance. So we only look at the positive root, so 12. Okay? That's how you would set it up and solve. So let's look at another one, number 4. Again, this is a leg, right? So we'd set it up as X squared plus 13.2 squared equals 14.4 squared. Okay? Then you would square and do all the same steps. So 13.2 squared is 174.24. Now we're going to round our answers to the nearest tenth, okay? But we're not going to round till we get our answer. So we don't have our answer yet. I know this goes to the 100th, but that's fine. We're going to leave it there until we get to our final answer. Okay, and then 14.4 squared is 207.36. Then I would minus the 174.24 to both sides. So minus 174.24, and I get 30, I'm going to write it up here. X squared equals 33.12. Okay, so still not done right. I have to square root both sides, and the square root of 33.12 is 5.75, blah, 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 blah. So we're going to round that to the nearest tenth. So 7 is the 10th, right? Since that is a 5, we're going to round up by 1 and be 5.8. So x would equal 5.8. And I forgot to label the first one. That should be centimeters. This one is miles. And that would be your answer. Okay, not too tough. Let's do one more. Actually, let's do number 5. So number 5, same idea, but this time C is the longest side. So I'd have 11.2 squared plus 11 squared would equal x squared. So this time you just square them, add them together. So 11.2 squared plus 11 squared, and you get 246.44 equals x squared. Okay, don't have to subtract this time since I just added them together, so I just minus, or not minus, square root. So the square root of 246.44 is 15.69, blah, blah, blah. So we're going to round 6 is the 10th, right? Since that is a 9, I'm going to round the 6 up by 1, so it would be 7. So it would be, or 15.7 kilometers would be what x equals. Okay, and that's my answer. Not too tough. Okay, that's the first section. Next section is the same kind of stuff, but this time it doesn't give me the triangle. It just gives me the A or B or C. So we're just solving for whatever isn't given, right? So this time it gives me an A and a C, so I need to solve for the B. So it would be A squared, so 3 squared, plus B squared equals 5 squared. Well, 3 is 9, and 5 is 25, minus the 9. B squared would equal 16, and then you square root both sides, and B is going to equal 4. And that'd be your answer. Okay, not too tough. Like number 12, it gives you A and B, so you have to solve for C, so it would be 13.2 squared plus 8.4 squared equals C squared, and then you just plug that into your calculator, right? 13.2 squared plus 8.4 squared is 244.8 equals C squared, and then you would square root both sides, and you're going to get 15.64, blah, blah, blah. Since that is a 4, you don't round up, so it would be 15.6. So C is equal to 15.6 meters. And that'd be your answer. Okay, not too tough. All right, next section. Determining if it is a acute, obtuse, or right triangle. So on this one, you are basically taking the two smaller sides, squaring them, adding them together, and then comparing that to the longest side squared. If the longest side squared is bigger than the two smaller sides, then it's going to be obtuse. If they're equal to each other, it's going to be right. And if the longest side is smaller than the other two sides, then it is going to be acute triangle. So let me show you how to set it up. So again, we're going to kind of do these in different parts and then compare our answers. So we're not setting them equal to each other. So we would do 9 squared plus 12 squared, and then over here I've got 15 squared. So 9 squared is 81, 12 squared is 144. Add those together, and you would get 225. Okay, 15 squared is 225. So is this bigger? No. Is it smaller? No. Is it equal? Yes. That means it's going to be a right triangle. And that's your answer. Okay, let's try another one. So this one should be pretty obvious since it's the same numbers here, but 9 and 12 squared added together, I know the answer. It's going to be 225, right? And then I've got the longest side is 17 this time, right? 17 squared. Well, 17 squared is 289. Well, the longest side, is it smaller than the two other sides? No. Is it equal? No. Is it bigger? Yes. The longest side is bigger, then it's going to be obtuse. Okay? It's a very obtuse triangle. All right. And that's basically what you're doing in that section. It's the same idea on this one. Let's do one more. Let's look at number 20 here on the next page. So 6 and 9 are the smaller sides. So 6 squared plus 9 squared. And then I've got 10 is the longest side, so 10 squared. Well, 6 squared is 36. 9 squared is 81. Add them together. It's going to be 117. 81 plus 36 is 117. Yeah. 117. And 10 squared is 100. So the longest side this time is smaller than the two other sides, right? So this is where we get a acute triangle. See? Very acute. Okay. And that's all you're doing on that section. Again, you're just taking the two smaller sides, squaring them, adding them together, comparing it to the longest side squared, and depending on how they relate to each other. The two smaller sides are bigger, it's acute. If the longest side's bigger, it's obtuse. If they're equal, it is a right triangle. Okay. And then the last section, this is finding the distance between 2 points. So again, this is where the distance formula came into play. So distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? And really all this is just the Pythagorean theorem, right? When we're on a coordinate plane, when you subtract or find the difference in the x values, that gives you your horizontal leg. And when you subtract your y values, you get your vertical leg. And that gives you the distance between these 2 points, which is your hypotenuse, right? So this is like a squared, and then this is like b squared. You add them together and then square root, and it should give you the longest side, right? Or the distance between those 2 points. Okay? So that's all you're doing here. And again, if it gives you the graph, you can just count. So like here you can count, oh look, it's going over 1, 2, 3. Or it's going up 1, 2, 3, 4, 5. Or you could also look at the points, right? This is at 1, -1. So the x value is 1. This x value is at 4. What's 4 minus 1? Well, it's 3. This x value is at -1. This one's at 4. So what's 4 minus the -1? Well, it's 5. Right? It just gives you the 2 legs. Okay? So then you would just basically use the Pythagorean theorem. Again, the same thing, right? Well, yeah. We'll do the distance formula in a second. So, and I'm actually doing the wrong side here. Who cares? So this is going to be 3 squared plus 5 squared, which is 9, plus 25, which is 34, and then you square root, and the square root of 34 is 5.83, which would round to 5.8. So 5.8 would be the distance here. And that would be my answer. Okay, what if it gives you a graph that is just a straight line instead of a diagonal line? Well, you don't need to use the distance formula on that one, right? You can literally just count. This is 1, 2, 3, 4, 5, 6. That's my distance. If it's a horizontal line or a vertical line, you can just count the distance. It is nice. You don't have to do the Pythagorean theorem or anything like that. Okay? But what if they don't give you a graph, which is something you won't have on your test, right? this is where you have to use the distance formula. So distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so you're going to have to use that formula. So again, it doesn't really matter which one you call x1 or y1, because even if you do it wrong, the difference is just going to turn into a negative, which when you square it is going to become positive anyway. So no matter what, you should get the same answer, even if you do it in a different order. You should still get the same answer. Okay? So, for example, let's look at number 30 here. So let's say this is my x1, and this is my y1, and this is my x2, and this is my y2. Right? So this is point 1, and this is point 2, is what I'm saying. So my distance is going to equal the square root, and my lights went out, and they're back on. Okay, great. Don't you love the power-saving measures of public schools? Okay. X1 is -2, right? So in my parentheses, I'd have -2 minus x2, which is minus -6. And then squared, plus y1 is 3, y2 is 2, squared. Okay, so -2 minus a -6. So when you minus a negative, you end up adding, right? So -2 plus 6 would be 4. So I have 4 squared. And then 3 minus 2 is 1, so 1 squared. Well, 4 squared is 16, 1 squared is 1. 16 plus 1 is 17. And then the last thing I'm going to do is square root. So the square root of 17 is 4.1, right? So the distance is going to equal 4.1. And that would be my answer. Okay, let's try that again. So distance is equal to, let's do number 32. So -7. Oh no, it's got to do my big square root, parentheses, then -7, minus 3 squared plus -7 minus a -1 squared. Okay, so -7 minus 3 is -10 squared. And then -7 minus -1 would be like +1, so that would be -6 squared. Well, -10 squared is a positive, so again, if you plug this into your calculator, make sure you use parentheses when you square. That's actually one of the more common mistakes in this whole unit, especially with the distance stuff, because you do get negatives here, where on a triangle you're not going to get negatives, right? So -10 squared. If you don't use the parenthesis, your calculator thinks of it incorrectly and it'll say -100. So you have to use the parentheses. So you'd get 100, and then -6 squared is 36, so plus 36. So 136. And then you square root last, and the square root of 136 is 11.66, blah, 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 which would round up to 11.7. So the distance is equal to 11.7. And that would be my answer. Okay. If you have any questions or concerns, ask your teachers. We're here to help. We want to help. You just got to ask us. So, again, any questions, let us know, and I will see you out there.